Hello everyone.
Hello, sir.
Let's wait for one more minute and then we'll start our session. All right, let's start the session. The first question is on your screen. With what minimum acceleration mass capital M must be moved on frictionless surface so that the mass small m remains stick to it as shown? The coefficient of friction between both of the masses is mu. Yes, Jen, right answer. Alright, I'll give you a hint. For this mass small m, there is a normal force acting in this direction. Suppose this complete system is moving over here with acceleration a. So normal force is acting in the right hand side direction. Mg is acting downwards. And because this mass wants to fall down, so friction will be acting upwards with the maximum value of mu n. Now this n is providing the acceleration, so we have n equals to ma. You have 1 minute to solve this question now. All right, let's proceed with the solution. In the vertical direction, we have mu n equals to mg. So substituting ma from this equation into second equation, we have mu ma equals to mg. M and m gets cancelled out. So from here we have mu equals to, oh sorry, we need the acceleration. So we have a equals to g by mu. That gives B as the right answer. आगे सबको समझ में? Alright. A block of mass 0.1 kg is held against a wall by applying a horizontal force of 5 Newton. If the coefficient between block and the wall is this, the magnitude of the frictional force acting on the block is. Okay, I'll give you a hint. In the question, there's a wall and a block of mass given 0 0.1 and a force is being applied over it this way. So making a free body diagram for this mass, we have mg acting downwards. No J and wrong answer. Mg acting downwards, normal force acting rightwards, and this wants to go down, so friction is acting upwards. Alright, you have 1 minute to solve this question. Shall we proceed with the solution, or do you guys need more time?
No, sir, please proceed.
Alright. The maximum value of friction is given by mu n, and as this mass is not moving anywhere in the horizontal direction, so we can simply say n equals to f. F is given as 5 newtons, so n is 5. The value of friction is coefficient of friction is given as 0 0.5, so my f becomes 0 0.5 into 5, that is 2.5. Alright, so 2.5 Newton is the maximum value of friction over here. Now, what is the value of mg? Mg is 0 0.1 into 9.8. That is 0 0.98 Newton. So the force of gravity is only 0.98 Newton. So my value of friction will not reach to 2.5. It will only stay till 0 0.98. So my answer for the magnitude of frictional force will be 0.98 newtons.
So
Clear
why
everyone?
mu's value used in mg?
I'm sorry.
Why isn't the that what do you call it? The coefficient of friction also applied when we're putting 0.98. Shouldn't it be multiplied to the coefficient of friction 0.5?
Where?
In the end, like when we're talking about the final force
This
over
is
there.
mg. I've only calculated mg over here.
Okay.
Got it?
Yeah.
This is mg force. I'm comparing friction with mg over here. Anyone else any doubt? Shall we proceed to the next one? Alright. Consider the situation shown in this figure. Find the tension in string AB, considering the pulley and string as frictionless and massless. No gen wrong answer. Listen, everyone. The tension between the masses and the rest of the strings tension will be different. No gen wrong answer. That means this tension and this tension are going to have different values. Alright, I'll give you a hint. Guys, note that um, to overcome the friction, there needs to be a sufficient force required. So, first compare what is the maximum friction and what is the maximum force that is applicable on the system. Shall we proceed with the solution? Alright. The force which is going to create motion in the system is the mg force acting on the zero point 0.3 kgs, which is zero point 0.3 multiplied by 10, that is 3 newtons. So if the acceleration is 0, so this 3 newton is going to be the same as the tension. And if we see the value of maximum friction in these bodies, the normal force over here is 10 and 10. So my friction will be mu n, which will be 5 newton and 5 newton. So for acceleration equals to 0, my frictional force is much greater than the external mg force which is required for the motion. So that is why everything will remain at rest, and this first body over here, the friction provided by this is sufficient to stop the motion, so no tension will be applicable on the AB part. So my answer will be 0.
So I didn't understand the last part. How is it sufficient?
This is F equals to 5 newtons, and the tension in the string or the mg force is only 3 newtons.
Okay.
If this mg force would have been greater than 5 and less than 10, then there would have been the involvement of my second body as well. But there is no involvement of this one. So the first one, the mass at B will be sufficient to stop the motion. All right.
Okay, so
Okay. A body of mass 60 kgs is dragged with just enough force to start moving on a rough surface with coefficient of static and kinetic zero point 0.5 and zero point 0.4 respectively. On applying the same force, that means the force is then continued in the rest of the motion as well. What is the acceleration of the body? All right, I'll give you a hint. Suppose this is my mass of 60 kgs and there is a force acting over it on a rough surface, and the coefficient of static friction will be the first force that we have to overcome. Alright, so to overcome the friction, this force should be equal to friction, that is static friction, which will be 0.5 into n. N will be equal to mg, so 0.5 into 600, that will give me 30 newtons. So 30 newtons will be the value of the force which is being applied as well. Alright, so now this 30 Newton is fixed and this 30 newtons is acting on the body in the rest of the motion as well, but the coefficient of friction has fallen down from 0 0.5 to 0 0.4, so the value of friction will change. You have 1 minute to solve this question. Yes, Jen, right answer. All right, let's proceed with the solution. The new frictional force, which is kinetic friction, will be 0 0.4 into 600, that will be 24 newtons. So there is a 6 newtons extra acting on the body. So force equals to mass into acceleration. So my A will come out to be 0.0 point, I'm sorry. Yeah, this friction will be 300 newtons and my friction force new one will be 240 newtons. So my new force will be 60 equals to 60 into A. That will give me A equals to 1 meter per second square. Taking G as 10, we have got this answer. So taking G as 9.8, we would have got A option as the right answer. Alright. A box of mass 8 kgs is placed on a rough inclined plane of inclination theta. Its downward motion can be prevented by applying an upward pull F, and it can be made to slide upwards by applying a force 2F. The coefficient of friction between the box and the plane is. I'll give you a hint. We have two different situations over here. In the first situation, downward motion is being prevented. The angle of the inclination is theta. And if, yes, Jen, right answer. And if the downward motion is being prevented, then the friction is acting upwards. Mg is acting downwards. The extra force is acting upwards, and a normal is over here. In the second situation, the box is to be made to slide upwards. So when this is sliding upwards, the frictional force is acting downwards. There's mg acting downwards, and this is the normal force. So these are the two different situations acting. We have to find out their equations, and using them, we have to find the relation between the coefficient of friction and the inclination of the plane. You have 1 minute to solve this. All right, let's proceed with the solution. Here, as the equations of motion, um, for that we have to split the force mg into its components. So we have over here, this is theta, so this becomes mg cos theta, and this will become mg sin theta. So we have F plus F equals to mg sin theta. Now my frictional force is equals to mu into N, and N is equals to mg cos theta. So my equation becomes F plus mu mg cos theta equals to mg sin theta. Similarly, in the second case, I'll get my equation as 2f minus mu mg cos theta equals to mg sin theta. I want to find the value of mu, so I'll have to eliminate f. So I'll simply multiply the first equation by 2, so I'll get 2f plus 2 mu mg cos theta equals to 2 mg sin theta. And subtracting both of these equations, I'll have 3 mu mg cos theta equals to mg sin theta. mg and mg gets cancelled out, and this gives me mu equals to 1 by 3 tan theta. So A is the right answer. Alright, let's take the last question for today's session. A block of mass m on a rough horizontal surface is acted upon by two forces. For equilibrium of block, the coefficient of friction between block and surface is. Shall we proceed with the solution?
So just a minute.
Alright.
So is the body at rest, like even after the forces?
Yes, it is at rest. It is written in the question for equilibrium of block.
Okay, okay.
Equilibrium means
So
rest.
just 1 minute then.
Yes, that's the right answer. All right, let's proceed with the solution. Making the FBD of this mass, we have this is our mass M, mg acting downwards, force F1 acting this way, and force F2 is acting this way, and theta is given in this manner. So if we split F2 into its components, we get this as F2 cos theta, and this becomes F2 sine theta. And we have normal force. So the friction will be acting here this way, which will be equal to mu n. So what equations do we have? We have n equals to mg plus f2 cos theta, and we have f, which is equal to mu n, is equal to f1 plus f2 sine theta. Now putting the value of n from first equation to second equation, we have mu into mg plus f2 cos theta equals to f1 plus f2 sine theta. Bringing this whole value in the denominator, we get A as the answer. Clear, everyone?
Yes, sir.
Alright, guys, that's all for today. Thank you for joining.
Thank you, sir.
Good night.
Good night, sir.